Think back to the generative AI boom of 2023 and 2024. The industry had created models with massive computational intelligence, but that intelligence was entirely trapped inside the confines of a simple chat window. These models existed in a vacuum. If you wanted the AI to actually accomplish a task, it required constant human intervention. A person had to physically highlight the generated text, copy it, open a new application, paste the output into an email or a code editor, and manually hit send. This animated diagram illustrates what engineers called the prompt bottleneck. Notice the massive funnel of data at the top, representing the AI's capabilities, squeezing into a severe traffic jam at this single, tiny node below before it can reach the target software applications. That pulsating red node represents the human operator. Because the AI lacked the ability to take action on its own, the entire system's output was strictly hard-capped by how fast a human could physically type instructions and click between browser tabs. By late 2024, the tech industry hit a breaking point. Generating thousands of words of text or lines of code in seconds was useless if a human still had to manually shepherd every single output to its final destination. Scaling intelligence required building systems capable of independent action. To unlock true technological scale, developers had to completely abandon the reliance on human-prompted steps. By removing the operator from the middle of the workflow, the data could flow freely, achieving genuine machine agency and setting the immediate stakes for the reality we live in today. Here in 2026, the solution to that bottleneck is fully deployed: Agentic AI. The primary differentiator is its power to autonomously architect and execute workflows. It accomplishes this from start to finish without requiring continuous guidance or permission from a human. These autonomous machines operate on a systemic foundation known as the agentic loop. This is a continuous, three-step cycle where the software is trained to observe its environment, reason through the necessary steps, and take concrete action. To see how this works in practice, look at a standard development request today. A human user provides a single, simple sentence: build and deploy a mobile app that tracks daily protein intake. The moment that prompt is submitted, the system enters the reasoning phase of the loop. It does not immediately start writing arbitrary code. Instead, the AI pauses to conduct internal strategic planning. We start with a single prompt block at the top. The system decomposes this request into a logic tree of 50 interconnected subtasks. It evaluates dependencies, calculates which components to build first, and highlights the exact pathway for execution, completely devoid of human input. Translating a single human desire into a comprehensive, machine-generated blueprint requires complex strategic logic. That capacity to independently plan is the critical first marker of true technological agency. With the internal planning complete, the agentic loop shifts into external action. The agent leaves its isolated environment to directly manipulate the digital world. This introduces the tool use phase of the loop. Tool use is the agent's ability to autonomously access and operate external software applications, navigating them exactly like a human engineer would. The agent rapidly executes multiple actions at once. It opens browsers to read documentation, communicates securely with private APIs, spins up remote cloud servers, and authors the required codebase across multiple languages simultaneously. But live deployments rarely go perfectly. During the server configuration, a mismatched security protocol triggers an unexpected hard error, and the entire code deployment fails. At this exact moment of failure, the difference between legacy and agentic models becomes obvious. A legacy generative system would halt its process, display an error text, and wait indefinitely for a human to instruct it on what to do next. In the self-correction phase, the failed output routes backward into an analysis module. The AI reads the error logs, deduces the root cause, rewrites its own code, applies the patch, bypasses the failure point, and successfully redeploys. Executing a predefined plan is just automation. True agency is the cognitive resilience to encounter an unpredictable roadblock, diagnose the problem, and conquer it independently. By 2026, the success of these loops in software development has spread to every sector of the digital economy. Because a single request can now trigger hundreds of autonomous subtasks, the sheer volume of work these agents can complete has rewritten the relationship between humans and computers. Routine technical execution, writing legal briefs, drafting architectural plans, or debugging enterprise software, is now handled by the machines. This eliminates the need for humans to act as step-by-step technical operators. This shifts the human's role. A single person no longer authors one asset at a time. They direct an entire fleet of autonomous agents working in parallel. Professionals have transitioned into managers of digital labor. Daily responsibilities now focus on high-level strategy. Workers spend their time establishing overarching organizational visions and setting strict, unbreakable ethical guardrails that dictate exactly how their agents are allowed to operate. The dynamic is clear. The autonomous agents do the heavy lifting of building the technological bridge, leaving humans solely responsible for determining where that bridge leads. In a world where AI can effortlessly architect, troubleshoot, and execute absolutely any complex plan you give it, the most valuable human skill left is deciding what is actually worth building.